In this video, I'll be presenting my refactorization of a text embedding method called the Similarity Encoding. This model is an implementation of the paper Similarity Encoding for Learning with 30 Categorical Variables. It adjusted the problem of 30 text data by embedding string into vector space representation such that similar string will be embedded closely together. The input of the model is a text file, with each line representing the string that need to be embedded. The output of the model is the embedded numerical vector space representation of each line in the input file. Right here we can see an example of the input file, with each line containing a word that need to be embedded. And right here we can see the example of the output file that the word offered is embedded into a vector space. The main idea of this model is to find a similarity measure of each string compared against with all other strings in the input file. The similarity measure can be many different measures, but for the refactorization, we focus on the Levenshtein ratio similarity encoder. Right here we have a Jupyter notebook on similarity text encoding. First, we need to import the necessary libraries such as NumPy and our refactorization class Similarity Encoding. Then I initialize the model with the embedding dimension of 300. Then we will read the dataset using the read dataset function, and the dataset we are reading for this Jupyter notebook is the input.txt file. By calling chain, we will chain the model using the previously read dataset. Since input.txt file contains 12 words, and our embedding size is 300, so the embedding shape output is 12 by 300. Then we write our output to a chain output.txt file. And here is a sample of the embedding output. The word is a bag, and then the embedded vector right here is in a dimension of 300. We can also make prediction by using our training data. For each line in the predict.txt file, it will be embedded by comparing similarity values to all of our training data. The embedded output is also in a dimension of 300. Then we write the predict output to a file. Here's an example of the embedding of the predict data. The word flower is embedded into a vector of 300. We can also predict the similarity between two strings. We predict the embedding of each of them and take the comparison similarity of the two embedded vectors. For the term Viterbi and engineering, the similarity between them is around 0.5. Here I provided an example evaluation on one of our group's benchmark, SEMI 2017. SEMI 2017 provides two sentences and their similarity score. I used the above similarity prediction function to predict the similarity between the two given sentences and compare the result to the ground truth similarity score provided by the benchmark. By using the model to embed, we get a mean error of 0.37.